Hello everyone, I'm Casper. Welcome to Testimony, where we help you become test automation engineers one slice at a time. And today we are going to conclude our three-part mini-series, trilogy on thread sleeps. And so over the past videos, and I really recommend you go and check them out. They'll be linked in the description of the video, and also they will pop up somewhere around here. I really recommend you go and check them out if you haven't. So we've talked about the thread sleeps and what they are. What exactly is a thread sleep? And we've talked about why they are bad, where the bad reputation comes from. And we've discussed at length why so many people treat them like they were the evil of the world. And so this may lead you to a very natural conclusion that they are basically a big no-no. And so in such a situation, why are they even there? Why do they exist? If everyone just scoffs at them, then what's the point in actually having them, in designing a functionality that is not needed or basically wrong by design? So today we are going to take a look at whether maybe sometimes there are situations where sleeps are actually needed. And so if you thought that the previous videos tell the whole story, and if you think that what you probably have heard about sleeps, and by that I mean basically always a huge pile of bad news, if you think that's the whole story, spoiler alert, it's not. So let's jump to our whiteboard. So as it often goes, we'll start with a little example. And before we start formalizing things, I always think that it's actually of great benefit to take a look at an example. And so just as we use an example to show you why sleeps are bad in many situations, now let's think of a counter example. So let's imagine that you are testing a functionality. You are doing API testing, for example, and you are doing a test which responsibility is to check out whether if you create some kind of resource on the backend side and then you see that it has been created and then did try to delete it, that it has actually been deleted. And since we are doing just an example, it's not really that important what kind of resource we're talking about. It may be a post, or it may be like creating a team on the backend side, which other people will then be able to add users to. So let's maybe stick to the team thing. So basically, the definition of the example would be that your job is to check whether everything is going smoothly when you are doing something like this. First of all, you are creating a team. So number one is create team. Number two is delete team. And number three, check if it's deleted. So this example may seem simple enough. So basically, if we tried and converted that into actual API calls, that will basically, of course, it depends on the architecture and the project, but let's not get into that much detail now. Let's just focus on the big picture, that generally this would translate into something like post something, then number two, and I'm talking API methods now. So number one would be the post method, then we would do some kind of a delete method. We could also do a get between them so that you are sure that it actually is there. So before we delete, we may actually go and get it, then we delete it, and then we get again. So basically, this maps in such a way that the post is the creation of the team, then get to make sure it has actually been created on the server, then we delete. So this is the second step, and then we get again to see that it has been deleted. And so this, like I said, may seem simple enough, but very often you may come across a situation which you have not really foreseen. So in this example, it may be that after you run your tests a couple of times, you see that you start having problems somewhere around here. So you may see that the delete goes through perfectly fine. However, the get afterwards sometimes gives you a positive and sometimes it gives you a negative. So sometimes it shows you that the get failed, so the resource, the team has actually been properly removed, but other times it doesn't do that. It just tells you that it's just still hanging in there merrily and happily. And so you may start to scratch your head over what is actually happening. You did all the API calls right, and sometimes after you delete and you do a get, you get a proper response, and other times you are not getting a proper response because suddenly your get is still returning the resource that was supposed to be removed in the previous step. And so this may actually provoke you to try and check what is happening. It may provoke you to start talking to your team and stuff like that. And you may come across a situation where sometimes you may learn that somewhere around here, for example, there's some caching going on the side of the server. And so there's some backend caching. And so if you just do a get immediately after the delete, you may come across a situation where sometimes it will go through when the backend is not occupied with anything. And sometimes it may not, because the backend needs some time in order to actually perform the operation to the fullest. And so this is this kind of a pesky situation where you don't really have anything specific to wait for. There isn't anything, since you are doing API testing, you can't really do a wait for something in the UI to happen, like for the team to actually disappear from a list. And there is no specific thing happening that would trigger your certainty over the fact that you can get the next thing. And so you run across a problem because you have this caching. You can't really go around it. There's nothing you can do about it because it's within the architecture of your application, and you still need to test this. You can't just throw your arms up and go, oh no, if there's caching going on, I don't want to have anything in common with that. You can't really, like in most of the situations, you won't be able to do that. And so you need to make do while still keeping in mind the problems that are happening here. And this is a great example of a place where you can use the sleep, because if you threw a sleep, I don't know, for 1 second or something like that, it depends on the architecture, of course. If you threw a sleep there, then suddenly you may get rid of the uncertainty, of the flakiness that, and I really recommend the video about flakiness we did some time ago. So you basically got rid of the flakiness, and the flakiness here was not because of your problems with the testing suite, and it was not because the application is malfunctioning. It just needs some time while not really giving you anything more elegant, let's say, that you can get a grip on. So you need to somehow still make sure that it goes through, and you may learn either through your exploration or through talking with the backend team, for example, that this usually takes a couple hundred milliseconds, for example. So very often, rather than refactoring the whole application in order to allow it to give you some signals that you can wait for, it's better to just use a sleep in such a situation, because then you just know that the cache problem will be mitigated on the test side. And similarly to this, we could also talk about something like performance testing, when you need to somehow mimic the user's interaction with the website under some kind of a heavy load. Very often then you will also find sleeps implemented in such a situation, because there may be that there is no real other way to actually mimic such a circumstance. There may not be anything specific to wait for, and like in our first example, the API testing, very often trying to devise a different solution just for the sake of not having the sleep curse word, of not having the S word, the sleep, within your framework, you are basically creating a hacky workaround solution that is just as bad, if not worse, because you are stretching your imagination and creativity to the fullest just to avoid using an instruction that was built with specifically these kind of scenarios in mind. You can think of a sleep as a failsafe if you can't really do anything else, or if using other things or other means of making sure the state of the application is ready to be tested, or the state of the application is mimicked in a way that was actually needed, then you can just use a sleep. If creating such a scenario actually entails more workarounds and like dirty hacks and tricks up your sleeve than just using a sleep, then maybe just use the sleep. So let's keep on playing the devil's advocate here. And now that we did some two small examples, I think we're ready to actually start and formalize things a bit. And so let's try and write down the specific things that the sleeps are good for. So first of all, this will be operations outside your control. So this is basically the first example that we did. Like, very often there will come times when you are going to come across situations which are outside of your control to some degree, or fully outside of your control, because that's how things are run in a given project or organization. You can't do anything about them, but you still need to test them in such a way that accounts for these problems. So very often you will find situations like the one that we have talked about. So such that there isn't really anything specific, explicit to wait for, and still you need to test the functionality while still maintaining the highest faith within your tests, because like we have talked in the previous videos, also those more about the philosophy of testing, and I really recommend those. Your goal is to create tests that are faithful to the truth and that are giving the most information that they can. So you are basically, your job is to create a framework that other can rely on, and to rely on them, very often you will need to take into account some really hacky solutions that other departments within your project have already implemented, and very often they are already set in stone and you can't really do anything about them, but you still need to be wary of them and to adjust your tests in such a way that they perform correctly. Number 2 would be the flakiness workarounds. Once again, we have a separate video on flakiness, and I really recommend you take a look at that in order to actually understand, because this is a very deep subject and it goes way deeper than we're going to be able to touch upon in this specific video. But the other one, I think, does a good job of being a primer into flakiness and giving you all the information about what flakiness is, how we can mitigate it, what's not a good idea, what is a good idea, and stuff like that. But in short, flakiness workarounds are a good fit for sleep statements because they are also outside of your control by nature. And so this ties a bit into the first point, but other than that, if there's some kind of a race condition happening, some things that are not always factors under your control, and which may cause you to not be able to actually use other means, and they cause flakiness, because not every operation outside of control may have to create flakiness, but now we are talking about those that do. In such a situation, it may sometimes be wise to use a sleep, and it's not a flakiness remedy. That's why I am using the word workaround here, because I am not advocating for the sleep statements, hard-coded sleeps, to be a remedy for flakiness. It's not. But very often you will come across situations where there's such a conglomerate of race conditions happening and things that are concurrently challenging each other and fighting for the execution time, that it may, once again, we come to the point that we have talked about during the example, it may be actually easier, faster and better for the good of the project to go for a sleep that can just wait out all those situations happening, rather than trying to stick to the rule of no hard-coded sleeps within your framework just for the sake of sticking to some rule. Because yeah, maybe that's going to be more elegant if you just show your code to a fellow QA, but in the real world, it's not about pretty code. It's about bringing the value to your framework so that you may help the team. And so sometimes when the landscape is particularly buggy and hacky itself, it may actually be better to use a thread sleep to mitigate flakiness. And sometimes just as a temporary solution or workaround, and in order to then be able to refine it in the future. But sometimes it's just kind of a workaround because it's better to just implement a thread sleep there that's going to wait for 1 second rather than spend 2 sprints trying to find a solution that does not use a thread sleep and saves you a whopping 200 milliseconds of execution time. Like, you should always remember that you are going to weigh these options. Like, it's always a balance. It's always a dance. Test automation and QA in general is never that clear cut. It's never something you're going to find in a handbook or learn on a boot camp. It's messy, and you will need to make some trade-offs. And very often in such a complex situations, when there's a conglomerate of flakiness problems happening in cascade, it may be better to just use a thread sleep in such a situation rather than trying to unwind this whole ball of problems that is going to be even more problems when you start to entangle it. So flakiness workarounds, that's also very often a good fit for sleep statements, either for some time or sometimes out of necessity for a longer time. Number 3 would be performance testing. And that's something that we have already talked about during the second example. Basically, when you are doing performance testing and you need to cover situations where there is some heavy load happening, for example, or there is some delay happening and stuff like that, very often it is useful to use sleep statements for such a situation, for such scenarios, because you can't sometimes mimic it otherwise, and you still need to somehow simulate it. And so in such a situation, performance testing, using sleeps may actually be very beneficial to your cause. And number 4, last but certainly not the least, is going to be debug solutions. So like I said, that one is the last one, but certainly not in the slightest. It's not the least important, because actually I think debug solutions are the biggest thing for sleeps, because yes, sleeps are messy, they are hacky, but they are also very easy to implement and they are self-explanatory. And these are also big pros of sleeps. They are quick to implement. They allow you to see the consequence of your actions or the consequence of the script's actions very, very quickly. And so because of that, they do have their place in debug solutions, because in debug solutions, very often you need to check something quickly. You need to make sure that something works this way or the other way. When there's some race conditions happening, you need to check whether if you wait a couple of seconds, it'll solve itself. If something is becoming laggy, very often you may slap a sleep on it to see how laggy it is, and if adding a couple of seconds actually mitigates the issue. And I'm not advocating, once again here, for using sleeps as a permanent solution for this, just as much as I was not being an advocate for using it as a permanent solution for flakiness. I'm not being an advocate of that here either. I am talking about debug solutions where time is key, when speed is key. Very often speed is key, because you need to learn what the problem is and understand it to the fullest before you can start and implement a more elegant solution. And in such a situation, you can't really understate how important sleeps are. This isn't, of course, something that is, I recommend, being commonplace in your framework. You should try and limit the usage of that within your framework as much as you can, but still, and especially considering that in like corporate or professional environments in general, temporary solutions do have the tendency to stick, and they have the proclivity to become permanent solutions. Like because of the forces of inertia. So you should be wary of that and not get sloppy with your design. But still, debug solutions are a great place to implement your sleeps, because even if this is just some hacky workaround, it may actually make you see where the problem lies, and so then you can try to refactor it into something more elegant and something more production ready. So I really recommend thinking about sleeps when you are stuck, because when you use them and you get unblocked, it may help you to actually alleviate the headache and to be able to start finding new means of actually solving the problem. And so, yes, in general, sleeps are a bad idea. They have the bad reputation for a reason. But I think that these examples that we have talked about today and the list of situations where sleeps are acceptable is going to be really helpful for you to understand that they are not all that bad, and that they do have the place within the test automation suite, or at least in working on the test automation suite when you are just debugging or creating some workarounds before you dive deeper into it. So just as the previous two videos, I believe, may have been helpful into understanding what threat sleeps are and why they are considered bad in many situations, I think this one, I hope it helped you understand that they are not all that bad. And I hope that the next time you come across the topic of sleeps, like during your interview or something like that, you will be able to give the whole big picture, not just talk about the bads that everyone is talking about. And now it came to my mind that maybe we're not going to stop at a trilogy. We're going to do a fourth part, because we've talked about what threat sleeps are, why they are bad, when they are good and acceptable. But I also want to provide you with a quick list of ways you can actually substitute for the threat sleeps. Because, yeah, it's cool to say threat sleeps are not good and hard-coded sleeps are bad. Yeah, that's cool. But what can I do instead of them? I think that's a very important question. And so I think we'll actually make this mini-series 4 parts. And I'll see you in the next one, where we'll just brush the final stroke and talk about when we don't want to use a sleep, or when we can't use a sleep, or when we shouldn't use a sleep. What should we use instead then? So I'll see you there. Thank you for your patience, and thank you for your attention. I hope it has been helpful. Please remember to like and subscribe, and to leave your comments, questions, and anecdotes in the both in the comments here on Facebook or on Instagram. Thank you very much, and keep on rocking.